Okay, the first question just says you have two functions, f of x and g of x, and the only thing that's important is that f of x is above g of x. It's greater than. So if you want, you can make yourself a rough sketch. Just come up with any graphs that satisfy this criteria. So there's f of x, g of x. As long as it's below, it doesn't matter where it is. And then your bounds are going to go from a to b. So let's say this is our region. We want perpendicular to the x-axis, so we're going to use dx on both of them. So if you know it's going to be dx, I know my bounds right away on both of them will be a to b. And here's my rectangle. And the first one is I'm going to have a square. So this is one side of a square. So this is just really f minus g. So I just need to figure out what's the area of the square. F minus g times itself, so f minus g squared. The thickness is dx. That will give you the volume of one cross-section integrated to get the whole thing. Half circle, same idea. So this is the diameter of the half circle. Again, this is the same as this, so this is going to be f minus g. Area of a half circle is pi half r squared. And then I just need to multiply by dx to get the volume. So the pi halves I'm going to go ahead and pull in front. The radius would be f minus g divided by 2, and then I have to square it. Make sure that this 2 is inside of the squared. Okay, the second problem. Your region is 3 minus x, which is just 1, 2, 3. And you're also bounded by the axes, so this is your region here. We're going to go perpendicular to the x-axis again, so we're going to use dx. This is 3, so I can find my bounds right away. So there's my setup. And we're going to do right triangles, isosceles right triangles with the hypotenuse in the xy plane. This is your xy plane. So this rectangle that's coming out of there, this is the hypotenuse of the triangle. So what that means is, here I'm going to draw the triangle over here a little bit bigger. So this matches up to this, and this is your hypotenuse, so this has to be the 90-degree angle, and I know this side is going to be 3 minus x. Okay, we need to find the area of this triangle. Area of this triangle is 1/2 base times height. This is going to serve as our base. We're going to actually have to create the height of this triangle. The height of this triangle is this. We're going to have to drop this down. But they told me this is an isosceles right triangle. So if this is 90, these have to be the same. So really, this is a 45, 45, 90 triangle that you have, that little half one. Well, if the whole thing is 3 minus x, this, because it's an isosceles right triangle, is actually 3 minus x over 2. It's got to be half of it. But then notice that this is the side across from the 45-degree angle. Well, isn't the height also the side across from the other 45-degree angle? So this also has to be 3 minus x over 2. So your area of the triangle is 1/2. Base is going to be 3 minus x, this whole thing. And your height is this piece, which would be 3 minus x over 2. So that's the area of the triangle. I think I kind of simplified this a little bit to be this. 3 minus x quantity squared over 4 dx would give you the entire volume.